Hello, and welcome to today's episode, where we dive into a vital topic for modern industry green chemistry in offshore operations. Offshore industries from oil rigs to marine engineering depend heavily on chemistry, from corrosion inhibitors to cleaning agents. But this same chemical can pose serious risks to both workers and the ocean environment. Today, we'll explore how green chemistry offers a safer, more sustainable path forward, protecting the people, productivity, and the planet. Green chemistry is all about designing chemical products and processes that reduce or eliminate the use and generation of hazardous substances. In offshore setting, where containment is challenging and ecosystems are sensitive, this approach is crucial. It reduces pollution, prevents toxic spills, and improves worker safety, creating cleaner seas and safer platforms. Green chemistry. This is all 12 of the green chemistry. But for the sake of the podcast, we'll only cover four. Green chemistry is guided by 12 core principles, each aimed at making chemical processes safe, cleaner, and more efficient. Let's explore a few that are especially relevant to offshore operation. First, prevention over treatment. Instead of managing pollution after it happens, green chemistry focuses on preventing waste before it's created. On offshore rigs, this means designing systems that minimize chemical discharge right from the start, protecting both the workers and the marine ecosystem. Second, designing safer chemicals. Traditional offshore agents like corrosion inhibitors or degreasers often contain compounds that are toxic or persistent in the ocean. Green chemistry encourages chemists to design new molecules that are effective but also biodegradable and non-toxic to marine life. Third, real-time pollution prevention. This principle focuses on detecting and controlling releases before they become a large-scale problem. In offshore environment, real-time sensors and automated system can identify leaks, spills immediately, allowing operators to respond quickly and minimize harm to both workers and the sea. Fourth, energy efficiency. Many offshore processes require high temperature or pressures. Green chemistry looked for ways to achieve the same result under milder conditions, cutting down fuel use and greenhouse gas emissions. And finally, inherently safe design. By choosing safer substances and milder processes from the beginning, we reduce the risk of fire, explosions, or accidental exposures, a major benefit in environment as sensitive and remote as offshore platforms. Here's a quick example. In the past, many offshore maintenance products used chlorinated solvents, effective but highly toxic. Now companies are switching to water-based or bio-based alternatives, drastically reduce worker exposure and marine contamination. This small change in formulation represents a huge step towards sustainable offshore practices. As you can see in the diagram there, the yarn is actually biodegradable, which could replace zip ties in incoming future. Now, let's do a pop quiz. Which green chemistry principle focuses on reducing waste at the source? If you guess it, the answer is C, waste prevention. Waste prevention, designing processes to minimize waste from the start, is at the heart of the green chemistry. Would you agree? I would say so. Implementing green chemistry directly enhances occupational safety offshore. Fewer toxic substances means lower risk of the chemical burns, respiratory issues, and accidental release. For workers, spending long shifts at sea, that's a major improvement in daily safety and long-term health. On the right side of the example of ISO 14001 certificate in Malaysia, and the left side is the benefits of ISO 14001. To sum up, green chemistry is more than a concept. It's a commitment to innovation and responsibility. By applying it offshore, we safeguard workers, protect marine life, and ensure our duties remain sustainable for generations to come. Thank you for listening, and remember, safer chemistry builds a cleaner ocean and brighter future.